Our solar system is made up of a lot of things. The biggest thing is the sun, of course, which makes up the majority of the solar system's mass. And then we have the planets, which come in various sizes, and many of them have moons, also of various sizes. However, that isn't everything. There are other things in the solar system, things that amount to the debris between the much bigger objects. Learn more about asteroids, how they were discovered, and how they might serve humanity's future on this episode of Everything Everywhere Daily. This episode is sponsored by Newspapers.com, your passport to untold stories and hidden histories. As the largest online newspaper archive, Newspapers.com offers an incredible journey through time, with papers dating back to 1690. Imagine exploring the news, events, and everyday moments that shape the history of the world around us. Newspapers.com puts over 900 million pages at your fingertips, offering a front row seat to the past. With papers from the United States, United Kingdom, Canada, Australia, and beyond, Newspapers.com lets you walk the streets of history, whether it's London during the Blitz, New York during Prohibition, or Sydney during the construction of the Harbor Bridge. For listeners of today's episode, Newspapers.com is extending a special offer. Use the code EVERYTHINGEVERYWHERE and enjoy a 20% discount on a subscription. That's Everything Everywhere at Newspapers.com. It's the perfect way to unlock the world of history. This episode is sponsored by Harry's Razors. I want to tell you a quick story. Several years ago, I was a podcast listener just like you, and I was listening to one of my favorite history podcasts. One of the ads on the show was for a company called Harry's Razors. I was extremely dissatisfied with the razors I was using at the time, so I figured I'd give these Harry's Razors a try. And it was a great decision. And I have been a customer of Harry's Razors ever since. I use Harry's Razors at home, and I've taken them with me on trips around the world. Not only does Harry's Razors provide a smooth shave, but they do so at a much lower price than their competitors, which, if you've checked out the price of razor blades lately at the store, that is not something to sneeze at. Don't settle for the status quo. You can blaze your own trail with Harry's. Get started with a $13 trial set for just $3 at harrys.com/everything. That's harrys.com/everything for a $3 trial set. I've done many episodes on all of the major players in our solar system. I've covered every planet, the sun, and even the hypothetical Planet X. However, this doesn't make up the entire solar system. Floating around between the planets are smaller objects that are known as asteroids. The first question that we have to address is, what is an asteroid? If you remember back to my previous episode on whether Pluto was a planet, astronomers have developed a definition to determine what is and what isn't a planet. There were three criteria which were set that had to be met for something to be called a planet. Number one, it is in orbit around the sun. Number two, it has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium. In other words, it's nearly round. And finally, number three, it has cleared the neighborhood around its orbit. Asteroids do not meet all three of these definitions. All asteroids meet the first requirement in that they orbit the sun. Some of them are large enough to meet the second requirement of having enough mass to be round-shaped. But no asteroid meets the third requirement, which is that they're big enough to clear out their orbit. In fact, as we'll see, asteroids are usually found with a whole bunch of other asteroids. One thing that some of you might be thinking is, what's the difference between an asteroid and a meteoroid? According to the International Astronomical Union, the same group that created the definition of a planet, a meteoroid is, quote, a solid object moving in interplanetary space of a size considerably smaller than an asteroid and considerably larger than an atom, end quote. So that's a pretty vague definition, but we can probably safely say that if we can observe it from the surface of the Earth, then it's big enough to be called an asteroid. The discovery of asteroids actually took some time. It was what I would call a rather deliberate accident, and it involved a thing known as the Asteroid Belt. The ancient people knew of the planets Mercury, Venus, Earth, Mars, Jupiter, and Saturn. By the late 16th century, astronomers had developed an idea of the distances of the planets from the Sun. And once they had an idea of the distances, something seemed a bit off. The gap between Mars and Jupiter seemed abnormally large. The German astronomer Johannes Kepler analyzed the data collected by the Danish astronomer Tycho Brahe and concluded, quote, "Between Mars and Jupiter, I place a planet." His guess was really just that, a guess based on his sense of proportion of the solar system. In the 18th century, Kepler's hunch developed into a much formal mathematical framework. A series of numbers that seemed to fit the distances of the planets was discovered. It was first proposed by the astronomer Johann Titius and later refined by Johann Boda, both Germans. A law known as the Titus Boda Law was named after them. The Titus Boda Law states that if you take a sequence of numbers starting with 0 and then go 3, 6, 12, 24, 48, etc., doubling the term each time, then add 4 to each number, and then divide it by 10, what you get is a close approximation to the distances of the planets from the Sun in terms of astronomical units. The actual distance of all the planets from the Sun up to Uranus is within 5% of the estimates provided by the Titus Boda Law. However, there was a problem. There was a missing planet between Mars and Jupiter. The Titus Boda Law seemed to confirm the suspicion of Johannes Kepler from so many years before. It implied that a planet hadn't been found between Mars and Jupiter. The missing planet was apparently discovered by Giuseppe Piazzi, an Italian Catholic priest, on January 1, 1801. The new planet was named Ceres, and at a distance of 2.8 astronomical units, it seemed to fit the Titus Boda Law. Just before, I said that the discovery of the asteroid belt was a deliberate accident. It was deliberate insofar as people were looking for it in the rough orbit where it was found. It was an accident because it was later determined that the Titus Boda Law was pretty much just pseudoscience. The location of Neptune did not conform to the Titus Boda Law at all, and there was no physical reason for it. It was just a series of numbers that happened to conform to the orbit of the planets by sheer coincidence. The discovery of exoplanets around other stars has subsequently confirmed that the Titus Boda Law has no scientific basis. Nonetheless, Ceres was discovered, but again, there was something wrong. Astronomers started finding other things in the same orbit as Ceres. In 1802, Pallas was discovered in the same approximate orbit. This indicated that Ceres wasn't the missing planet. Rather, it was something different. The astronomer William Herschel dubbed them asteroids. In 1804, Juno was discovered, and in 1807, Vesta. Throughout the 19th and early 20th centuries, a host of asteroids were found, each one seemingly smaller than the one before it. By 1921, over 1,000 asteroids had been discovered. All of these minor planets were in a belt around the Sun, which was dubbed the Asteroid Belt. People have some very mistaken views of the asteroid belt, mainly due to movies and television. It's often viewed as a region filled with rocks. If you were a spacecraft trying to navigate the asteroid belt, it's often assumed that you'd have to be dodging rocks so they don't get hit constantly. That is not what the asteroid belt is like. If you were in the middle of it, odds are you would see absolutely nothing. Yes, there are objects in the asteroid belt, but they're spread so far apart that you couldn't possibly see one if you were on another asteroid. The current estimate is that there are 1.1 to 1.9 million asteroids larger than 1 kilometer, and probably many million more that are smaller. Despite the seemingly large number of asteroids, they don't add up to very much. All of the asteroids in the asteroid belt have less than 4% the mass of our moon. The next big question with regards to the asteroid belt was how it was formed. One theory held that the asteroid belt was at one time the location of a planet, just as the Titus Boda Law suggested. According to the theory, at some point in the early solar system, a Mars-sized planet or smaller either broke up or was destroyed. This theory has subsequently fallen out of favor because there isn't nearly enough mass in the asteroid belt to have once compromised a planet the size of Mars. The current popular theory is that the material in the asteroid belt was simply never able to coalesce into a single object because of Jupiter's gravitational interference. Despite not being as sexy as the larger planets and moons in the solar system, asteroids continued to be studied. And it's a good thing that they were, because what was found about them has groundbreaking potential. There are, roughly speaking, 3 categories of asteroids: C-type, S-type, and M-type. C-type asteroids contain a high proportion of carbon along with rocks and minerals. They are the most common, making up about 75% of known asteroids. S-type asteroids are made up of silicate materials and nickel-iron. These asteroids are less common. And finally, M-type asteroids are composed of mostly metallic iron and nickel and are relatively rare. It's the composition of these asteroids which has such enormous potential. If humans are ever going to build large-scale space stations or spacecraft, they're going to need an enormous amount of raw material to do so. These materials can't come from the Earth because of the difficulty and energy required to get them out of the Earth's gravity well. Asteroids make for an almost perfect source of raw materials in space. They're rich in metals, and there are millions of relatively small objects that could be towed in full wherever they're needed in the solar system. Asteroids are abundant and contain precious metals like platinum, gold, and rhodium, as well as rare earth elements that are used in electronics and other advanced materials. However, they also have abundant amounts of iron and nickel, as well as the most precious substance in space, water. The total economic value of asteroid mining is mind-blowing. A single asteroid that was visited by a spacecraft was estimated to have an economic potential of $100,000 quadrillion. To put that into perspective, the economic value of everything on Earth, including all the objects in real estate, is only somewhere between $400 trillion and $5 quadrillion, depending on the estimate you want to use. We're still a long way from asteroid mining, but asteroid exploration has already begun. A few missions have done flybys of asteroids, but they were only able to take quick images. To date, there has only been one mission to an asteroid in the asteroid belt as an objective. In 2007, NASA launched the Dawn mission. It orbited the largest asteroid Ceres, as well as Vesta, another very large asteroid. The Dawn mission was great, but what was really needed was a sample material from an asteroid. This finally took place in 2016 when NASA launched the OSIRIS mission. OSIRIS traveled to a near-Earth asteroid named 101955 Bennu. It was launched on September 22, 2017, and arrived at Bennu on December 3, 2018. It spent over 2 years analyzing the surface before landing on October 20, 2020. It then took a sample of the asteroid and returned it to Earth. It arrived back on Earth with its sample on September 24, 2023. I should note that the asteroid belt is not the only place in the solar system with asteroids. Some have their own orbits around the Sun, and other asteroids can be found in groups. The orbit of Jupiter has 2 groups of asteroids that have been captured and are now stuck in orbital resonance with Jupiter. Collectively, they are known as the Hildian asteroids. There are currently over 5,000 known Hildian asteroids that are gravitationally locked in Jupiter's orbit. The generic term for any asteroid that is gravitationally caught in a planet's Lagrange point is a Trojan asteroid. And there are probably millions more asteroids floating around the solar system that we are totally unaware of because we simply can't see them. Asteroids aren't as enchanting as planets. They don't have colorful atmospheres, and there's certainly no possibility of life on them. But in terms of potential future usefulness, they might just be the most valuable things in the solar system. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Keever. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.